All right, today we're going to look at the first part of section 5.3, which allows us to use our derivative to help us determine where a graph is increasing or decreasing. We've done these questions before, we just haven't used the derivative before. So the first thing I'd like you to note is the interval that I'm marking in light blue. And those are the intervals where the graph is increasing. Now what does that really mean? It means is that the slope, if we draw a tangent line at any point on that graph, that it's going to be a positive slope. So you see one tangent line drawn here. On the left-hand side, it's positive as well as once we get over here. Now, the interval in between the two is where we get a negative slope going down from left to right, and we call that a decreasing interval. And we should also note that at the point where it changes, we end up with a horizontal tangent line, which means where it's zero. So that is what we call a critical point, where the derivative is zero. And that's the first part of 5.3. And you can see there are some basic conclusions that we can make, that if the derivative is positive, that means it's increasing, so that's where we get the blue sections. If the derivative is negative, then we get the decreasing, which is the green. And if it's zero, we get the critical points. And to test if something is a critical number, we have what's called the first derivative test, and this is in your textbook if you need to look it up later. And basically what it says is that anytime your derivative changes from being increasing to decreasing or from negative to positive, that it's going to either be a low point, which we would call a relative minimum, or a high point, which is a relative maximum at that point. So we look in at this graph. Here we see that it's switching from being positive to negative. We call that a relative maximum point. And when it switches from negative to positive, we get a relative minimum point. Relative in that it's not for the whole graph, because clearly this graph has no limit. It's going up forever and down forever. But for that general area, there is a maximum point. So let's consider this question, which says find where it's increasing or decreasing, and then the coordinates of any relative extrema. And this is a constant function, and it's not a difficult question. It's a straight horizontal line. It's never increasing or decreasing. If we take the derivative of it, it is always zero, which means that there is no increasing or decreasing interval. Therefore, there are no relative extrema. There's no minimum or maximum. It's just a straight horizontal line. Whereas for question B, we will find a different result. So let's go ahead and find the derivative of this function. Now I'm going to treat it as really 1/2 x minus 3. And so my derivative is going to be 1/2. And if I just consider the original graph, I'm not going to go into a great deal in graphing it, but we have a y-intercept at minus 3. We have a slope of 1/2, so it is going to be going up 1 and then over 2. So we'll be right about there maybe, and we get that kind of a line. Where is the function increasing? Well, it's always increasing no matter what. This graph is always going up from left to right, which is what the derivative tells us. It says no matter what, the derivative will always be positive 1/2. Well, what's that positive 1/2? Well, for a line, that's your slope. These two numbers are always going to correspond to one another. And if we look at the graph of the derivative, so the graph of the derivative is the derivative equals 1/2. If I put this as being 1/2, it would be a straight horizontal line. The slope always is the same for a straight line. Now we're supposed to talk about the intervals of increasing and decreasing. So to write that down, I would write increasing interval is all numbers, and there is no critical point or no relative extrema. There is a critical point, I suppose, everywhere where the derivative equals 0, but that's not a specific point. It's just a general. And then we get a graph that would be difficult to graph all by itself. So this one we could graph easy. It's a straight line. This one we could graph. It's a horizontal line. What do we do when we have something we can't graph easily? Well, we take the derivative, and we're going to get x squared plus x minus 12. Where is that going to be, positive or negative? And there's a couple different ways you could look at it. I like graphing it. If I had a choice, and if I had a choice, I would graph it by completing the square. So if I divide 1 by 2, which is 1/2, and then I square it, I get 1/4, and then I would subtract 1/4, So I end up with x plus 1/2 squared minus 48 minus 49 over 4. And so if I were to graph that, at negative 1/2 and negative 49 over 4 would be down here. And then it's going to go up. The question is, where does it cross there? Because I can clearly see that the graph's going to be increasing over this interval. Actually, I don't even need to worry about where it crosses. And it's going to be decreasing there. So I already know the answer from completing the square. That if this equals my derivative, which it does, that it is decreasing from negative infinity all the way to negative 1/2. It's increasing from negative 1/2 to infinity. And there's a critical point, which is a relative minimum point, because it switches from being decreasing to increasing from left to right, at negative 1/2 and negative 49 over 4. Now that's just one way to do it. You could have also tried factoring, assuming I did that right. I could have made mistakes with my numbers. But that's the basic idea. And they get more complicated, as you can guess. And here's our assignment that we're going to work on. And I'll be glad to help you as you work.